Hey everybody. Today I'm showing an example of hypothesis testing for a population proportion. Here's the problem I'm going to work through. I recommend pausing the video and trying this on your own before proceeding, if you can. A large university advertises that 65% of its students graduate in 4 years or less, but I suspect that that proportion is too high. So I go out and I collect a simple random sample, finding 68 of 120 respondents that did graduate on time. Is there sufficient evidence to reject the university's claim? I want to make a decision at significance level alpha equals 0.05. In this case, I'm going to choose a one-sided alternative that the population proportion is less than 65%. A one-sided test is appropriate here since I don't really care if the university is underestimating its 4-year graduation rate. If they're actually graduating more people than they say they are, that's probably a good thing. I'm only concerned that they might be misleading the public and that their graduation rate is actually less. We now assume that the null hypothesis is true, that the population proportion is 65%, and we compute a test statistic. That's going to be a z-score, and the formula is right here. I talk a lot about that in my previous video in the Normal Knowledge College Statistics course. I'll throw a link up to that up top in case you haven't been following along the whole course and want a little bit more information about that test statistic. In this case, our p-hat is 68 divided by 120, the sample proportion. It's about 0.567. The sample size n is 120, and our null hypothesis value p0 is 0.65. We plug in. We do a little bit of arithmetic, simplify all that, and we get z is about negative 1.91. So that's less than what we would have expected if the null hypothesis were true, if the university's claim were true, but probably not radically less. We compute the p-value of the test using a CDF of the standard normal distribution, the cumulative distribution function, and that returns the probability of randomly getting a value less than negative 1.91 in the standard normal distribution, the shaded area I have here. And that corresponds to the probability of randomly getting a p-hat less than what we actually got in our study. You should compute that using technology. Tables exist, but I strongly recommend against those. I use R, and the command is pnorm. So we're doing pnorm of negative 1.91. The resulting p-value is 0.028. So that's less than our significance level alpha, so we're able to reject the null hypothesis and conclude that the university has been overestimating their 4-year graduation rate. One small warning on that, this means that data like ours would still happen about 2.8% of the time if the null hypothesis were actually true. So there is a risk of a type 1 error here. In a sense, the p-value is quantifying that risk.